Swayam Prabha. Digital India. Educated India.
Welcome to the lecture of Statistical Modeling in R. In this lecture, we are going to look at visualizing normal distributions. So, normal distributions are also called Gaussian distributions. Before we proceed, we need to install the package Visualize. So, you can use the install.packages command, and within single quotes, you can give the name of the package and set dependencies equal to true. So, the reason we set dependencies equal to true is because if the package is dependent on other packages which are not installed, then those will be installed as well. So, once you install, we need to load the package. So, I am giving library followed by the package name. In this case, it is Visualize. So, the notation for a normal distribution in R is norm, which is called NORM. So, Visualize function, it will help you graph the distributions. It will also highlight the area corresponding to the lower tail, bounded, upper tail or a two-tailed section. It will also provide you the mean and variance of the distribution on the plot. So, Visualize.norm is the function that we are going to use for a normal distribution. So, let us look at the syntax for Visualize.norm. There are 4 input parameters. The first is stat. It is the statistic to obtain the probability from, and the default value is taken as 1. The next is mu, which is nothing but the mean, and it is equal to 0, and it is the mean of the normal distribution. So, if none of the values are given, the mean is automatically taken as 0. The next is SD, which is nothing but the standard deviation of the normal distribution, and the default value is 1. Following that, we have a parameter called section, and it tells you how you want the statistic to be evaluated, whether it is lower tail, upper tail or a two-tailed. So, the default value for section is lower. So, after loading the library, we are going to give the function Visualize.norm. We are first going to look at the left tail normal distribution. I am supplying a value of 2 to stat, and I am taking the standard values of distribution. I am also giving the section as lower here. Now, this falls on the left of the given stat value. So, let us look at the distribution once you run the command. So, here I have a snippet. It is a normal distribution with mean 0 and a standard deviation 1, and the probability of getting a stat value less than or equal to 2 is 0.977. So, on the x axis here you have the z statistic, and on the y axis here you have the probability density. So, the area under the curve is 1, and the area up to a stat value of 2 is equal to 0.977. So, now let us look at the right tail normal distribution. So, instead of section is equal to lower, I am going to give section is equal to upper here. Now, this will give you a normal distribution that will fall to the right of the stat value. So, let us see how the plot looks. So, I have changed the section from lower to upper here. Even for this plot, I have maintained mean of 0 and the standard deviation of 1. So, here you can see the area is highlighted here. So, this is the area that corresponds to a stat value of greater than equal to 2. So, now if you compare left tail and right tail, we know the area under the curve is 1, and on top left I have the left tail normal distribution, and I have a corresponding area of 0.977. and on the bottom right I have the right tail normal distribution. The area corresponding to the shaded region is 0.0228. So, if you add both these values you will get 1, and if you try to superimpose one on top of the other, you can see that this area is nothing but this. So, let us look at a two-tailed normal distribution. So, I have changed the section from upper to bounded here, and I need to supply both the lower and the upper limits. So, the lower limit I am taking here is -2 and the upper limit is +2. So, this gives me the probability that a value is bounded between these two limits. So, that is shaded as blue here in the plot, and that probability corresponds to 0.954. So, instead of section equal to bounded, if you give section equal to tails, then you will see the tails are highlighted and the corresponding probability is 0.045. The probability of getting a value less than or equal to -2 and greater than equal to 2 is 0.045. So, to summarize, in this lecture we saw how to visualize a Gaussian distribution. We also saw how to interpret the plot in terms of probability, and we looked at the plots for left tail, right tail and two tail normal distributions, and under two tail we saw how does a bounded section look and how does a tail section look. Thank you.